Can you guys believe we made it to the week before Thanksgiving already? It's crazy. This week we're going to be learning how to take an improper fraction and convert it into a mixed number and vice versa. On the screen here you're seeing that I have 5 thirds. They're thirds because it takes 3 of them to make a whole. Now here's something kind of crazy. That stick that divides the numerator and the denominator, that's actually a division bar. So in order to solve for this using a standard algorithm, I could just say 5 divided by 3. I know that 5 can be divided by 3 one time with 2 leftovers, and that's how I'm going to create this mixed number. For some of you, though, drawing it out is going to be what you need to do at the beginning to understand what we're actually doing when we do this conversion. So looking at my screen, you'll see that I have put 3 together to make one whole. Because they're thirds, that's how I know that 3 of them would make up a whole, and I have 2 leftover pieces. So if I had 5 thirds, that's exactly the same as saying I have 1 and 2 thirds. In a cookbook, it's never going to say 5 thirds. It's always going to have the mixed number. So why are we making you learn this? Because when we add and subtract with mixed numbers and fractions, we're going to be converting between mixed numbers and improper fractions all the time. So, in fact, we can go the reverse way, starting with a mixed number and then turning it into an improper fraction. So looking here, I've got 3 wholes and I've got 1 little piece left over. It takes 4 of them to make a whole, so I know that that piece is a fourth. And I can see here on my model that it actually does take 4 of them to make the 1. And I am going to do that for all 3 of my wholes. That's going to give me 12 fourths. And then I had that 1 little fourth left over. So all together I have 4 and 4 and 4, which is 12, and 1 more, which would give me 13. 13 what? 13 fourths, because the size of the piece does not change. And we're going to teach you like a little visual shortcut called the Texas method, where you can just multiply the denominator by the number of wholes and then add your leftover pieces. But we really want you to understand what you're doing when you apply that little shortcut. So we're going to be showing you this a lot with fractions. And then I know it's the week before the break, and your brain might not be ready for this, but what we're going to try to do is start adding and subtracting with fractions. So let's say that I had a half and I wanted to add a sixth. The pieces are not the same size, so I can't join them together. So the first thing I'm going to do is look for a common denominator. I can turn a 2 into a 6 to make all of the pieces 6. So that's what I'm going to do. And I'm going to put my little insult times 3 times 3. And according to this math, I have made an equivalent fraction. 1/2 is exactly the same as 3/6. So I'm going to drag that model out and prove that that is indeed the case, and it is. And now that they're all the same size, I can join them together. If I had a half and I was adding 1/6, that would give me 4/6 altogether. But in order to figure that out, I needed to make that common denominator first. Now, if I was taking STAR test or something, a standardized test, this answer would not be an answer choice. Why? Because it's not in simplest form. So we're going to also be applying that skill we practiced a lot last week, where you look for common factors in the top and the bottom. Whatever you do to the top, you do to the bottom. And when we simplify, we're always using division. So according to this, if we divide the top by 2 and the bottom by 2, 4/6 is exactly equal to 2/3. It's just simpler. And I'm going to drag those pieces out so that we can prove that it is the case. Now, believe it or not, our subtraction is going to get even more complicated than that. But we're not going to take you there until after we get back from Thanksgiving break. So this week, let's just stay comfortable simplifying, making equivalent fractions, and learning how to convert mixed number and improper. And when we hit back from the break, we will make sure that we dive into a little bit more complicating algorithms with adding and subtracting mixed numbers. You made it through a big landmark of the year, so congratulations, and we look forward to practicing with that this week.